Next, we would like to invite speakers from Siemens and Hanuman Automation. Mr. Milind Kulkarni, Chief Manager, Business Development, Factory Automation, Siemens Limited. Milind started his career in Siemens at Nashik, where he was involved in various functions like automation and drive system testing, product testing, quality planning. Mr. Sreenivasulu, Executive Director and one of the founders of Hanuman Automation. In 2013, he also started Profuse Infotech to provide IT solutions and services. Please welcome both on the stage.
Good morning, ladies and gentlemen. We have been listening about different ideas since yesterday to improvise the operational excellence and overall performance with latest trends and ideas based on Industry 4.0 and IoT. Yes, this is definitely a need of an hour, and the industries are gearing up towards harmonizing and implementing this effectively, and that's the transformation or the change that we say digital transformation. However, there's something which is also quite in control and in our hands to improve the performance or operational excellence, and that is by way of energy conservation. So my topic today is how we can help ourselves with energy data management solutions integrated into the existing production systems. That's the subject which I will dwell upon. I have my friend and our solution partner for EDMS solutions, Mr. Sreenivasulu. He already has some successful reference at his credit, so he will talk about it after I make you run through the concept of EDMS implementation. So the objective is clear. We want to integrate as a plug-on existing automation platform energy management solution. That's the whole idea. Now, these are the three concepts or ideas which are being quite rigorously followed by industry in general towards the performance elevation. For example, reducing time to market. Everybody wants to be quick there and deliver the new demanded products to the market. And if this is required, then one has to have excellent flexibility in the manufacturing setup. Then only you can readapt your manufacturing setup to produce new specified products based on the market demands, because market is really volatile and then the demands keep changing and fluctuating. But of course, these two topics are not our focus topics for discussion today. Our focus topic is increasing the efficiency of manufacture generally, and this is the optimal utilization of available energy resources and how do we ensure this. This is how I will take you through this session. Now, pain points. Generally, we are interfaced with industry, all of us, since quite long, and then we know there are plenty of dark sides of the setup that is prevailing in many of the places. For example, there is no transparency today in terms of who is consuming how much energy and whether it is legitimate. So there are two things missing. One, there is no benchmarking, and two, there is no transparency. Now, friends, let me focus furthermore. If I need to optimize the energy consumption, then what is that is most important for me? First and foremost, I know what is the consumption in practice. And I also have the benchmark values. It means there is a need surely to first evaluate as to do X, Y, Z steps in the manufacturing, I need to consume so much energy. This is the information which can be achieved by doing the energy audits and benchmarking the audit results to the specified levels as per the process consultants, for example. The infrastructure that is prevailing in any manufacturing setup today is also very heterogeneous. It's not homogeneous. You will never find complete setup done by one particular automation supplier. It's never the case. And that is where it becomes all the more challenging to pick up the rightful energy data from different islands which are prevalent. Because if you look at the manufacturing setups today, although we are talking a lot about integrated automated setup, we are still having quite a bit of island approach. So the approach is easy. Evaluation is the key, which is in between. If I have to do the proper EDMS, that is Energy Data Management Solution, then I have to first know, then I have to evaluate the information that I have, and then I have to realize the optimization tricks or techniques so that I can improve the general energy efficiency of the plant. Generally, a lot is spoken these days in terms of sustainability initiatives from every corporate, that energy efficiency is something which we should focus. We should use motors that are energy efficient. We should use lighting systems that are energy efficient. We should use drives, for example, to control the motors to lead to energy efficiency. This is one aspect of it. The other aspect of it is energy services. So this is through the complete value chain of energy deployment in the manufacturing setup. You continuously keep tracking whether the consumption is on the right track or it is more or it is less. Now to do that, what is most important and required is you need to have a proper energy data management system. Now this system primarily should comprise of what? It does not demand really an additional hardware except metering. Metering is also prevalent to a large extent in many manufacturing setups, but unfortunately our mindsets are tuned to relating energy to electrical power. And that's not the fact. When we talk about any manufacturing setup, the energy is used there in various forms. Pressurized air used in the manufacturing setup to run the pneumatic is used in so many different forms in the manufacturing setup. And when we are talking about energy data management solution, we are more talking about a comprehensive approach where we are not only focusing on electrical energy, but we are also focusing on other forms of energies that are used on the shop floor. Now, if this is required, I can always make the process audit and energy audit to know what is that is required to produce X output, benchmark values. However, I need to do the appropriate metering. Now, if it is electrical energy, it's very easy to make the metering. Yeah? But for other forms of energy, one has to think of innovative ideas, how the energy in those forms, like water flowing, like steam, like pressure airline. This is very important because a lot of times you see there are leakages in these utilities which result into loss of energy. Whatever is required to produce is anyway required and consumed, but besides that, a lot of it is wasted on account of leakages, and that's the challenge. If you have the benchmark values, if you have a metering system by which you capture the complete information of various energy resources that are used in the manufacturing, then it's very convenient to conclude where I am on track and where I am deviating. And once I know that, then there can be an alarm system established, there can be analytics incorporated. But first and foremost, I need to have a proper data, and with that data, I have to bring out relevant information which will be a meaningful information from the data. Because data is a raw, bare data. And energy metering systems will only help you collating the data. The tools that we talk about should not only do the collation of the data, but besides that, it should also offer proper reporting and analytical capabilities by which one can draw proper conclusions which can lead to specific actions, thereby saving energy and improving the efficiency of the plant. So this is in a nutshell what kind of energy forms we use in the manufacturing. And and besides the energy supply, energy media can be electricity, can be gas, can be steam, can be pressure, compressed air. In production process, we have machines, equipments and processes, they consume energy. We have drives, we have water that is used, that's also a form of energy. We have HVAC applications. For office areas, that's also a form of energy. And compressed airs, what is important is look at this and then start looking at it in a different perspective, because usually everybody is relating themselves to improving the energy performance for improving production KPIs. For producing X output, I need Y energy. By consuming same Y energy, if I produce more than X output, I have done a great job. This is usual perception. But it's also important to retune our mindsets a little bit. Instead of talking merely about production KPIs, we too can talk about energy KPIs. Because production should be a fallout. Energy is the resource that you consume to achieve the production. So don't always focus on production. It has to come. So one is own philosophy, because everybody wants to go green and also advocate that they are green. So that's one of the reasons. Also, as a responsible citizen of global setup and Mother Earth, we have to be conscious about legitimate consumption of energy in any case. Carbon footprints, yes, and there are reward systems prevalent in various government setups and machineries to reward those people who show reduction in carbon footprints. So, corporate social responsibility in culture of the organization. Beyond that, aligning ourselves with the norms specified by government and fitting us into the framework of Go Green initiative, which is usually driven by everybody, is what is helped by EDMS solutions. The programs which are mentioned here are binding programs in EU. They are not so stringently followed in the Indian context. However, time is not far when we see such energy efficiency programs will become mandatory in Indian context also. This is the will: identify, evaluate and realize. This is what I am talking about. And most importantly, this center part of the slide that you see is starting with energy policy. It means a corporate house who wants to have this kind of approach should have it in their policy, that yes, we would like to go green in a systematic, step-by-step manner. So first there has to be a policy. There should be a target defined that by so and so timeline I will achieve this much energy optimization, something like that. Then, based on the policy and targets that you set internally for yourself, there can be a planning. And then based on that, you can go into the implementation. Implementation will involve metering techniques, because not every energy form that is used will have appropriate metering in your plant. So that will be some investments. Then control element, which are nothing but the PLCs, is not uncommon in any manufacturing setup today. So connecting these meters to PLCs is very easily possible, by which you start collating the information. SCADAs are anyway available and present in most of the manufacturing setups, so you can have all the energy data from various places collated centrally and brought into one place. So you need only, after the appropriate metering, plugging on of the EDMS tool, which will take this data from the SCADA and then do appropriate analysis and then provide the required reports. Savings can be enormous. I have a case study, because Sreenivasulu is with us, and he will talk about one successful application which he has done. He can really make mention about how it can really show significant energy saving. It's important, friends, because people generally are very convinced with the approach of EDMS. The moment we start discussing the investment that are required, then everybody takes a back step. That's not a right approach, because you have to look slightly differently here. Penny invested today will give you back pounds tomorrow, for sure. And with that approach, let us not talk about the investments in absolute terms. Let's see, if I invest so much now, what could be my ROI? In what time span I recover this investment in complete, and then after that, whatever comes is free, bonus to me. So complying to legal standard, ISO 50001 is what people say they want to be compliant with, and if that is the case, then they need to have the energy data management solutions in place in any case. Also, there is a trend of nowadays, I can see this trend in big manufacturing setups. Management wants the energy allocation done cost center wise. Within the manufacturing setup, there are identified cost centers, and they want to know now which cost center is consuming what. So you can have the reports also produced after collating the information cost center wise. And then you could have the collated benchmarked values of required energy consumption cost center wise. And then against that, what is the actual, this can be brought out of this kind of reports. Yes, it's also important that one might wish to further integrate the energy consumption data into the ERP systems. And that's how you can actually put it into the complete holistic manufacturing process of your plant. So one success story which we have done with our EDMS solution, the key energy resources that were used in this manufacturing plant were power, electrical power, water, nitrogen, some other gases and heat. 400 meters were the actual meters to meter the consumption, and 300 virtual meters, because for measuring the consumption of nitrogen or gas or heat, there could be an indirect methodology of metering. So this is kind of virtual meters. And of course, the SCADA was there, the PLCs were there. So it was easy to connect those meters, capture the information into the SCADA, and then deploy over the EDMS. So generally, we could demonstrate a saving up to 30% of their existing consumption at that point of time, and this became a keyword for us, and then we got quite interesting opportunities offered by the same customer to expand the scope of such solutions in other areas too. So the whole idea is plant to production, the complete manufacturing setup may be integrated partly or fully, or maybe in islands we can still have an integrated data management for energy consumption. This is possible. So finally, if you see the sequence here, we are coming to bringing out a wonder figure, energy per batch. If you produce something in batch, and what is your energy consumption per batch? If you see this ratio changing for good, it means your solution is working good at helping you to improvise your energy efficiency. So energy data management brings transparency on the machines, how much they consume in the line and also at the factory level. So energy data management on all levels, right from the field level, control level, operator level, where there can be machine-wise KPIs shown and depicted onto the HMI devices on the machines. Management level, summary of the information for the management, and then further integrated into the ERP level, enterprise level. So we have two products which can be offered to realize this. One is entry level, which is called as power rate, which gets integrated on our SCADA directly. And it helps generating reports which are good enough for certain specific requirements. It has certain boundaries. However, it does not give you the full-blown reporting possibilities, which is a key expectation, because this is like once you get a test of it, you want to have more of it. And then the next full-blown energy data management product that Siemens offers is big data, which is a very elaborate tool, and it can offer any kind of reporting and analysis that could be required from the raw energy data. This B data is a high-end tool, as I mentioned, and this can work along with the existing setup. It can work in isolation as a standalone energy data management tool also. So if one wants, you can integrate this B data on the SCADA, that is WinCC, or you can integrate this with our DCS, that is PCS7, so that you integrate your energy data management solution into your automation in the production. Or if you don't have this, it can still work as standalone, and you can integrate it to the existing controls which are prevalent in the plant and directly capture the data from these controls. This is possible. So measuring, monitoring, supervising, and then managing, that's the sequence in which one has to operate. So what you can achieve from this data, this is the last slide which I will emphasize, and I'll hand over to Sreenivasulu. Monitoring is common. Many people and many tools can do it. Controlling is also not a very difficult task. You know this is a consumption which is more than required. You can switch off non-critical loads, bring your demands below maximum demands, and avoid penalties and fines. Easily possible. Many people do this. Energy accounting, now the actual usage of this tool starts from here. You can do the proper accounting, cost center wise in your shop floor. You can allocate costs per energy resources. You can have the reports generated per energy resources. Then you can start predicting your energy demands. It's very important, because the moment you are in that position to predict what would be your future demands, then you can have optimized buying of various energy resources. Because for electricity, we have a contract with the state electricity boards, but for other energy resources, usually we have one rate contract and that's it. But if you can predict your demands well, then you can have your stocks in place well, and you can always do bulk buying based on your predictions. And this can lead to significant energy saving. Then you can further draw energy efficiency measures and implement them and try to be compliant to ISO 50001 so that you can start advocating in a market that you are a green company, which also adds value to your portfolio in general. And yeah, then that's how you finally prove to the society that you are too environment friendly. So you get your benefit, you get your pockets burden reduced. At the same time, your name and fame is improvised. So the energy parameter monitoring, if you see, this is overall consumption. And very interestingly, the red part that you see is something which is undue, uncalled for. With appropriate EDMS solution, you not only see what is your overall consumption, but with appropriate analytics, you can find out what is undue consumption. And then work on this to reduce this so that your overall efficiency goes up. So that's it from my side. Reducing the non-value adding energy consumption is the ultimate outcome or achievement of proper EDMS implementation. I hand over to Sreenivasulu to take to the next.
Thanks, Milind. It's a difficult task after the great speakers to start. Anyway, we are running out of time. Just let me get into directly what the case study was. It's actually a campus software IT park, like 60 acres of campus, where you have almost 12 buildings scattered to different places. Each building to building, you have minimum of 500 to 600 meters. In a total, almost 3 kilometers surrounding. Like what they wanted was for this. Anyway, some of the buildings were existing, some of them are going to come. For these all buildings, they wanted to have centralized monitoring and control. And load shedding. Load shedding in the sense where you have a contractual agreements with the electricity board. There they wanted, if they cross the limits, they wanted to have a load shedding. And the reports and trending and charting. Where here again, alarmings, like when you trip the breaker, before that they wanted to have alarms, like 3 levels of alarmings. Like example, maybe your demand is there 10 MVA. If you have crossed 8 MVA, then give an alert saying that you have crossed so and so. Then if it crossed 9 MVA, give an alarm saying that it's going to trip in some time. Like it's almost 90% of your energy is crossed. Then when it crosses 100%, like 10 MVA, immediately trip the breaker. So that's where, like that they wanted to have each building level. Like one building may be having 10 MVA, another building will have 5 MVA, another building will have 4 MVA, similarly. And energy consumption, building wise they wanted, building wise and floor wise at the same time, even not only floor wise, again lighting, how much energy it is consuming, UPS, how much energy it is consuming, maybe chillers, even lighting also when it comes to floor lighting, how much it is, external lighting, how much it is, and what are the critical loads they are consuming, what are the non-critical loads they are consuming. That's what they wanted to have. For that, we have given a solution with Siemens controller, that is PLCs and SCADA, and on top of it, a small energy management tool. What it's like not a big tool, where you can test of it, how energy management is going to be. So that way, we have given for all the 12 buildings, you have a centralized control system and at the same time, local control system. Where local control system, like this is the local control system, where you have all the energy meters. Each building wise you take maybe 100 to 150 energy meters are there. Floor wise, even loads wise, it is connected for all the outgoings and all. This energy meters gives the data to PLC. It's like data acquisition. And this local PLC can control means do a load shedding to your load and load balancing it can do, what it is actually required. Also, we have this PLC to other PLC to communication, means like building to building. Two local PLCs communicate on the same network, and at the same time they can report it to the central processor. And a SCADA for visualization is like where you can monitor what all the breakers are switched on, or maybe what the data is, energy is consuming, just monitoring and data archiving and controlling also. On top of it, it's like power rate. What it does exactly, power rate when you need to have power rate, you need to have SCADA. Without SCADA, you just can't do it only with power rate. And what we can do with power rate, first thing is like, where it has simplified our work. Normally, without power rate kind of application tools, if you want to do load shedding, you need to write lots of logic in the PLC, where you need to have a comparison, what the energy is consuming and what the demand is there. We have to write lots of comparisons and do a controlling. But with the power rate, you have a readily available blocks, where you can do, where you can do all the data collection and conditioning, and then compare the data. It is like just one block where it even minimizes your PLC memory also. Generally, if you write, when you compare all the blocks, you need to write lots of logic. There it's going to consume lots of memory in the PLC. But with the power rate blocks, you don't need to write so much of logic. It is just add and block. Just drag that block and write what your set point, and where you have to generate alert, where you have to generate alarm, where you have to generate trip. You just give the data, it's going to do your job. That's where even our programming job, it's just minimized. And again, we have a faceplates, which is displayed in the SCADA. Like, you can monitor the energy, and you can even enter the set points and alarm levels. And you have Excel-based reports. Generally, many SCADAs, people they say like, we have a reporting system. But actually, when you look into it, we'll have a reporting which is like their proprietary kind of things, where you cannot export it to the Excel or PDF files. So that's where here, PowerRate is having a tool where you can directly export the data into Excel. Also, you can generate Excel reports where like what your cost center, energy cost center, that data comparison and pie charts, bar charts, everything can export it to the Excel. This is what the solution we have given. It's a total of 3,000 meters, this ring. This is a fiber optic ring, where even if there is a damage in the wire or cable, you don't lose the data. So there is a communication with all the PLCs. This is building-wise PLC, each building-wise, and this is centralized processor, which is redundant processor. And why we need redundant processor here? Maybe you can go with the small normal standalone processor, but still this data is important for us. So like main thing is here where we are scheduling, like truth tables are met here. What are the truth tables we create, and it's been catered to all the other PLCs, do this job, do this job. The scheduling is done in the main station. So that's where we wanted to have a redundant system. And from here connected to the SCADA, where we have energy reports, even monitoring, control, your dashboards, all the charting, historical data is archiving, everything is being done here. So this is all going well with the system, and even client was happy. There was a planned maintenance for 2 days in the plant, total in the building. That time they had to shut down the SCADA system. After, again, when the maintenance was completed, and then when they switched on, they found out there was no data for last 2 days. Then they have shut down the SCADA system. That's where generally no PLC will save the data. When SCADA is up, then only your data is going to archive and data is coming to the SCADA. That's where they have come up with, again, some more requirements saying that even if there is a shutdown in the SCADA, even if there is a break in the cable going to SCADA, they don't want to lose the data. How it can be achieved? That is one more thing. And with what we have given the reports, like cost center wise reports, and like example here, what we can say, earlier you take utility block PLC. there were 2 PLCs in the utility block. Utility, and one more thing, there is a parking MLCP here also. MLCP, they didn't have the automation system. They had only manual system where jet fans were controlled just manually by switching on, by knowing that CO2 level and CO level, they go and switch on the manually the jet fans, and ventilation system was going on. So that's where they were losing lots of energy. So we have studied that how much was going the data, manual collection we have taken, whatever they have collected the manually, and studied, we have implemented this control system where you can do it. So like when the CO level is high, your ppm levels are high, automatically switch on the jet fans, and when it comes down, and you can hear jet fans, you can run in a low speed and high speed. That's where even you can save the energy. Instead of running at common speed, and again ventilation fans. So that's where even they could see lots of difference. Like once automation is done and it is reported to the energy management, what happened when they have compared, you can compare by using power rate, you can compare previous month and this month, even maybe previous year, this year, the data easily. So when they have compared that data, when they didn't have automation, once they implement the automation, they could see huge difference in this, in one block itself. Similar fashion in all other blocks they have done, and they could achieve whatever they have invested. So that's where, again, what they have popped up is data loss, one thing, and they wanted to implement even for water consumption at the same time, even diesel consumption. This is what they wanted. Data loss should not happen, and for water consumption also they wanted to have similar kind of reports, and diesel consumption, and how, so like per unit, what is the diesel is consuming, how the generators are going to take. And again, they wanted to have KPIs on the web client, maybe wherever they are there. So this KPIs they wanted to see. And smartphone applications, like normal generator reporters, whatever it is, their KPIs and all they can see in the smart. That's what they wanted. For that, again, we offered a solution with B-Data, where it is actually an energy management system, energy data management system, where it is independent of SCADA or anything. You can integrate any PLC or anything. Like you can take Siemens or Rockwell or any other. Let it be X, Y, Z. You can directly integrate it to the PLC. Directly integrate to the B-Data solution. With this, we have again given one more energy box. What this energy box actually? It's an IPC, means panel PC. That's where the main data loss, what we were talking earlier, data loss. This is going to take care of the data loss, this energy box. What it does is, let us go back to this one. See, now there was a break in this cable, or maybe there was a planned shutdown of, planned or unplanned shutdown of this one. So that's where here, in this place, we are going to have an energy box, which takes all the data and pass it to your B-Data server. If maybe due to some unknown reason or maybe due to planned schedule, your B-Data server is down. Now, this, whatever the energy box is there, is going to take care of the data acquisition and archiving. That it stores in the, it's like whatever the capacity it is having, maybe 1 GB or 2 GB, 10 GB, whatever the capacity it is having, it stores in that itself. And once the connection is established between B-Data server and the energy box, automatically it syncs with the data and sends to the energy B-Data server. So that's where there is no data loss. This has been proposed, and we are going to execute in a, like almost it's on the process now. And coming to us, we are Hanuman Automation Private Limited. We are a system house and system integrators for especially like process, industrial and building automation sector. And started in 2010. A small team of almost around 25 people we are there. And we built all control panels like PLC, MCC, IMCC, and even like whatever the panels we build, even you take PCC panels, it is with intelligent, like all the breakers. You will know predictive maintenance also. Like you can predict when your breaker is going to have the problem, because we have then Again, control systems like all other control system applications, and we are authorized dealer of S7200 smart PLCs and EDMS solutions of Siemens. Also, we have a dedicated team for this kind of big data, like you say, big data applications, where you have AS400 or BPIX kinds of this one. So that kind of, we have a dedicated team for that to integrate ERP solutions and all. And with that, I thank everyone for giving me the opportunity. Thank you.